Good afternoon to all. Myself Manoj, Kumar, Department of Electrical Engineering, IIMT College of Polytechnic, Greate, Noida. I have to discuss overview of microcontroller 8051. What is the microcontroller 8051? This is a small chip. There are they have 14 pins. This is the introduction of 8051 microcontroller chip. Contained introduction, pin diagram, block diagram, memory organization, registers, addressing mode, timer and counter. Let we go. I will discuss one by one topic. Introduction. An example of for a CISC processor, Harvard architecture, collection of 8 and 16-bit register and 8-bit memory location, and external memory can be interfaced. This is a pin diagram of microcontroller 8051. There is a 40 pin P1 point P4. There is a 4 port P0 and P1, P0 and P1, P2 and P3. This is a pin 1, pin 2, pin 3, 4, 5, 6, and 7, and 8, and 9, and so on. 40, 39 pin. There is a collection of 40 pin. Okay. This is a port 1. Port 1. Uh, Port 1 is a 8-bit data store. P1.1, P1.0, P1.1, and so on. P1.7. This is a port 1 pin. This pin is used to input or output pin. Then port 0, port 0 is a 8-bit data collection. P0.0, P0.1, and P0 0.7. This is a P0 port and P2 port, P2 port, and similarly P0 and P1 port. Similarly P2 port, P2 port, P2.20, 2.1, 2.2, and so 2.7 is a P2 port, and P3 port, P3.0, 3.1, P3.2. This is a P3 port. There is a pin diagram of 8051 is a 4 port, and one particular port it is a consist of 8-bit data, and it is a cover of 32 pins according to pin diagram. 32 pins of input or output pins. Okay, and remaining 8 pins. This is a ground pin. 20 is a ground pin. Uh, uh, 2 pins 18 and 19 is the crystal oscillator pin. This is the working of filtering of signal, and VCC pin, and PSC1 and ALE or EA pin. 31 and 29 pins are the control of naval signals, and 9 pin is a reset pin. This is the device of is a follow of reset. This is a this 9 pin is a device is off. It's called the reset pin, and the 40 pin is BCC pin and supply pin. It is a supply to microcontroller 8051 and start turn on. It is used to turn on the 40 pin. Okay, so this is a pin diagram of 8051. Pins of 8051. This is a VCC pin 40. VCC provides supply voltage to the chip. The voltage source is 5 volt, and this is a ground pin. Ground pin, pin is 20. Ground pin. This is a XTL1 and XTL2 pin 19, 18. These two pins provide external clock. Pin of 8051, reset pin 9. Reset it is an input pin, and is active high, normally low. Upon applying a high pulse to reset, the microcontroller will be reset and all values in register will be lost. This is the pin of 8051. ये pin number 31 this is a external access pin. The EA pin is connected to ground to indicate the port is stored externally. For 8051 E pin is connected to VCC. Means active low PSE and program restore enable. This is an output pin and it is connected to the OE pin of the ROM. ROM is the read-only memory. This is I will explain next slide. This is the pin of ALE pin 30 address latch enable. It is an output pin and it is active. 8051 port 0 provides both address and data. The ALE pin is used for demultiplexing the address and data while connecting to the G pin of the 74LS S373 latch input port pins. The four ports P0, P1, P2, and P3. Each port uses 8 pins. All input-output pins are bidirectional. Bidirectional means it is a input and output, again output, and again the output to input. This is called bidirectional. All input-output pins. Pins of input ports. These 8051 has port input ports 40, pins 32 and 32, 39, port 1, pin A1 to 8, P0 to P0.02, P0.7, port 1, pin 1 to 8, P1 bracket P1.12, P1.7. Port 2, pin 21 to 28, P2, P2.0, P2.7, port 3, pin P10, 17, P3, 3.0, 3.7. Each port has 8 pins named P0X, X equal to 0, 1, 2, 3, and so on, 7. P1X, P2X, P3X, EX is a P0.0 is the bit 0 least significant bit. LSB means of least significant bit of P0. Example, P0.7 is the bit 7 most significant bit of P0. These 8 bits form a wire. Each port can be used as input or output bidirectional. Port 1, pins 1 to 8. Port 1 is denoted by P1, P1.0, P1.7, P1 as an output port. Write CPU data, the external pin P1 as an input port. Read pin data into CPU bus. Port 3. Port 3 pin denoted by 10 to 17 pin. All are pin is input-output pin. Although port 3 is configured as an output port upon reset, this is not the way it is most commonly used part. Port 3 has the additional function of providing signal serial communication, signal RXT, CST, external interrupt, INT0, INT1, timer, counter, T0, T1, external memory, access, WRRD. This is all are timer and counter signals. This is a block diagram of 8051 microcontroller. This is every part is a function. I will explain. This is a external interrupt IT0, IT0, INT0, INT1 internal interrupt controller. This is a CPU oscillator. This is a crystal pin. Crystal XTL1 and XTL2 is a crystal pin to filtering of signals to provide of oscillation that we get to the CPU get to the interrupt control. This is a on-chip ROM. This is a read-only memory. This is a interrupt signals to given interrupt controller. This is a bus control. Bus control, there are 3 types of signals: ALE, PSE1, PSE-EN, VAR, EA, VAR. Okay? This is the 3 signals to control by using bus control. There is a this block of 4 port input-output ports P0, P1, P2, P3 on chip RAM. This is a RAM, random access memory of part of memory. This serial port TXT, RXT signals. This is a serial signal, serial port signal. This is a timer counter. This is a timer counter 0, timer counter 1, T0 and T1. The overall concept of block diagram of 8051, this is a overall discussion of interrupt control, CPU, oscillation, on-chip ROM, or read-only memory, on-chip RAM, or read random access memory, bus control, 4 input-output port, serial port, timer counter 0. This is overall complete block diagram of microcontroller 8051. I will discuss and next. Memory organization of 8051. Memory is a vast role of it is an important role of microcontroller. Microcontroller need of vast memory. This is there are a lot of different types of memory are used in microcontroller. First, memory organization of 8051. Memory are two types. First is a RAM, random access memory, and second is a ROM, read-only memory. Random access memory are further classified into two ways. The first internal memory and the second the external memory. Internal memory is internal memory exists of internal part of microcontroller, and external part of memory are added externally. This is called external memory. This is a different size of external memory are connected to the microcontroller, and ROM and RAM. ROM read-only memory, or RAM random access memory. ROM is a permanent memory and RAM is a temporary memory. So RAM or ROM memory are further classified internal memory or external memory, data memory or program memory. Okay. Input-output ports with the programmable pins and arithmetic logic units, working registers, clock circuit, timer and counter, serial data communication are classified in further slides. Specific features: 8-bit CPU with register A and B, 16-bit PC, DPTR, data pointer, 8-bit program status, 8-bit stack pointer, 4 kilobytes internal ROM, 120 bytes internal RAM, 4 register banks, each having 8 registers, 16-bit bytes, which may be addressed at the bit level, 80 bytes of general purpose data register. A 8051 microcontroller, different type of registers are contained data. So their register, what is the register? Register is a small size of memory to store the data. One register it store 8-bit data 0 to 7. It is called register. There are two different types of register are used in microcontroller: general purpose register and special function register. General purpose register, this is a general purpose register. It store 8-bit data. So general purpose register are classified in different way to confirm. Specific feature: there are 32 input-output pins arranged as 4 8-bit ports T0 to T3, 2 16-bit timer counter T0 and T1, full duplex serial data receiver transmitter, control register, TCON, TMOD, SCON, TCON, IP, IE, 2 external, 3 internal interrupt sources, oscillator, and clock circuits. Program counter and data pointer. They are both 16-bit register. Each is to hold the address of byte in memory. PC contains the address of the next instruction to be executed. DPTR is made of 2 8-bit registers, DPH and DPL. DPTR contains the address of internal and external code and data that has to be accessed. This is a program counter and data pointer. They have contain 16-bit register. 16-bit register. It is called two register are required. One register is contain of 8-bit data. It is called of register. Each to hold the address of byte in memory. PC contain the address of the next instruction of to execute it. A and B CPU register totally 4 general purpose register or working register. Two of these, A and B, hold result of many instructions. Uh, Two of these, A and B, hold result from many instructions, particularly math and logical operation of 8051 CPU. The other 32 are in 4 banks, V0 to V3 of 8 register each. Accumulator is used for additional, subtraction, multiplication, division, Boolean, bit manipulation, and for data transfer. This is a accumulator register. There are a lot of functions are performed. This is a addition, subtraction, multiplication, division, Boolean, bit multiplication. Many show data of transfer, but B register can only be used for multiplication and division operation. Okay. This is a 8051 flag bit and they are PSW register. This is a 8051 flag. This is a 8-bit data store. This is a 0, 1, 2, 3, 4, 5, 6, 7. This is a XO, overflow, RSO, reset 0 to RS1, F0, AC or carry flow. This is a register to address LSB least significant bit, NSP most significant bit. This is a XO parity flag. This is called a parity flag. OB overflow flag. RS0, RS1 are a register bank status. This is just select by register to RS1 or RS0, RS1 to RS0 to RS1. This is a selecting of banks of register. FO user defined flag. AC flag, auxiliary flag, or CY is a carry flag. The program processor status word PSW, this is a bank register to select of RS0 to RS1. RS0, RS1 is a 00 is a select of bank 0, RS1, RS0, 1, RS10, this select of bank 1, RS01, RS1, RS00, RS11 is select of bank 2. This is a RS1, RS2, all of 1 is select of bank 3. This is a selection of banks register. This is a X parity flag. This is a parity flag. Example of overflow auxiliary flag. Overflow flag are to add of two binary numbers and overflow the addition of two binary numbers to carry of overflow of large number, which called the overflow flag. Okay. This is a blank register, PSW register, RS1 and RS2 register banks. This is a column to indicate 1011 RS0 0101 register. This is the column is indicate represent the register bank 0, register bank 1, register bank 2, register bank 3. This is a RS1 value 1, RS0 1 0. This select of register bank 0. RS10, RS01, select of RS register bank 1, value of RS11 or value of RS00, select of register bank 2, RS111, RS011, a select of register bank 3. Two flag bits are stored in PCON, power control register also. They are the GF1 third and GF0 second bits. This is a two flag bit are stored PCON control register also. Then they are the GF1 and they are general purpose user flag bit 1 and 0 respectively. They can be set or cleared by the program. For more details, you can refer in the next book. This is a this is a third position, third and second bit are count of GF1 or GF0. Stack in the 8051, this is a register E to access the stack is called the SP stack pointer register. This is a another type of register to call stack register pointer. The stack pointer in the 8051 is only 8-bit wide, 8-bit data store, which means that it can take value 00 to FFH. When 8051 forward up to of the SP register contain value of 07. This is a stack pointer. This is a 00 to H to SFH. This is a divided of memory location address. This is a R0, R1, bank 0 registers, R7, register bank 1, register bank 2. This is a register bank 3. Bit. This is a divide. This is the area. Is a bit addressable area, and this is a general purpose area. This is a memory location of special function register, general purpose register, to divided of area 32 bytes are this area of collection data, and 16 byte bit addressable area, and store and general purpose area is stored 80 byte number of bit 16 to 8 128 bit addressable 000 to 7FH. This is a memory address. Okay. Input output port programming port 0 pin 3239 when connecting 8051 to external memory. The 8051 use port to send address and read the instruction. 16-bit address and P0 provide both address A0 to A7. P2 provide address A8 to A15. Also, P0 provide data lines P0 to D7. When P0 is used for address data multiplexing, it connected to the 74LS373 to latch the address. ALE pin. The ALE pin is used for demultiplexing the address and data by connecting to the G pin of the 74LS373 latch. When ALE 0, P0 provide the data D0 to P7. When ALE 1, P0 provide address A0 to A7. The reason is to allow P0 to multiplex address and data. This is a different type of addressing board are used in 8051 microcontroller. This is a addressing board. Different type of addressing board are used in the 8051 microcontroller. First, immediate addressing board, and then second, register addressing board, direct register addressing board, or register indirect addressing board, and index addressing board. There are 5 different type of addressing board are used in microcontroller 8051, the way in which the instruction of is specified. I will discuss one by one of addressing board to give it below. Immediate addressing mode. This is the immediate addressing mode. Immediate data is specified in the instruction itself. Immediate data are transferred to move is a command of immediate addressing mode. Move a hash 65 hash. This is the address data. A is a register to move a data contain and move of 65 addresses. This is a immediate data. Move a hash a. This is a move R6 hash 65. This is a data. This 65 is a move of 65H. This is a move DPTR pointer 22343H. Move P1 has 65H. This is the immediate data. This is the programming of immediate data addressing mode. This is a A. This is a B R6. This is a different type of register. Memory location are used, then data one location to another location are moved immediately. It is a called of immediate addressing mode. This is a programming of immediate addressing mode. This is a move A, move VA, move RA6, move DPTR, move P1. This is a programming of microcontroller 8051 immediate addressing mode. This is a register addressing mode. Move RN A n equal to 0 to 7, add A to Rn. This is a different type of data contain, and Rn also contain of different type of data, and add the data plus A memory and Rn contain of different type of data, and our result of addition of A and Rn data. This is a register addressing mode. Register addressing mode are contain move DPL to RS6. This different type of data move command RE2 data move to one register to another register and one location to another location. This is a register addressing mode. This is a direct addressing mode. Although the entire of 120 bytes of RAM can be accessed using direct addressing mode, it is the most often used to access RAM location 30 to 7FH. Move R0, this is a register 40H, this is a location. This is a direct addressing mode. It is include the register data are swap 40H, 56H to A. This is a move data A to 56, 56 to A. Move A 4, move A R4. This is the programming of direct addressing mode. Move 6 to copy R2 to 6. Move R6 to R2 is invalid. The move R6 to R2 is invalid. Move 6 to copy R2 to R6. This is a valid point to data of R6 to transfer in R2 register. This is a valid region, and move R6 to R2 is invalid region. So always transfer the data R6 to R2. This is a direct addressing mode. To complete of programming, I will discuss and in detail in next lecture. Register in direct addressing mode. In this mode, register is used as a pointer to the data move A at the rate RI, move content of RAM location where address is held by RI into A. I equal to 0 or 1, move at the rate R1, comma B. In other words, the content of register R0 or R1 is sources of or target in move, add, and subtract B instruction. This is a register in direct addressing mode. This is a register in this register and direct addressing mode. In this mode, register is used as a pointer to the data move A. A is a space memory accumulator register at the rate RI. RI data is indirectly addressing indirect to move of register accumulator move content of RAM location where address is held by RI into A. This is the last and one index addressing mode and on chip ROM access. This mode is widely used in accessing data element of lookup table in entries located in the program space ROM at the 8051. Move CA at the rate A plus DPTR's data pointer transfer register A equal to content of address A plus DPTR from ROM. This is a ROM memory location, and A is the accumulator DPTR data pointer registers because the data elements are stored in the program code space ROM of the 8051. It is used to instruction move C instead of move B. Move the C is code. Move is a this is a C is a code. Move is a command of index addressing mode on chip ROM axis. This is a this is a move CA. Move C is a code. A is a accumulator at the rate A plus DPTR. DPTR is a different type of register, data pointer transfer registers, and A is a accumulator. This is a overall explanation of index addressing mode and on chip RAM. This is point. Thank you everyone.